thank you for coming to Microsoft Ignite, and thank you for just about packing this room here today. You know, on the product team, we spend the entire year looking forward to days like this, where we get to share all the new innovations and, for you, all the new opportunities that are in the latest version of products like Windows Server. My name is Cosmos. I'm a program manager on the CoreOS team at Microsoft. A little later, you'll hear from Adi, who's also a program manager on the CoreOS team. And in this session, we're going to be talking about Storage Spaces Direct. Now, this is the nth year that I've done this session at Ignite about Storage Spaces Direct. And so we thought we would do something just ever so slightly different this year, which is, for the first time, we're actually not going to start from the beginning. We're not going to start from the sort of introductory, what is Storage Spaces Direct and what does it do? And so by show of hands, who is already at least a little bit familiar with Storage Spaces Direct? So this is what I thought, just about everyone. So instead, what we're going to do is we're going to talk a little more about how it works and why it works that way. And we'll focus on what's new for Storage Spaces Direct in Windows Server 2019. So we've got a packed session. We have a ton of stuff to get to. And I think we should probably just get started right away. So you can't have any conversation about what's new for Storage Spaces Direct in Windows Server 2019 without starting with the most obvious new thing, the thing that's staring you in the face. And that's Windows Admin Center, which is the new face of Windows Server, and especially the new face of Hyper-Converged Infrastructure on Windows. Show of hands, who's heard all about Windows Admin Center all week? Wonderful. All right, now, show of hands, who's actually installed the thing? Oh, that makes me happy. It is at least half of the room, but only maybe half. So we'll start now with just I want to give you a quick tour of how Windows Admin Center looks for Hyper-Converged Infrastructure, and then we'll get into a lot richer and more depth demos. So let's start. For those of you who may not be familiar, it sounds like you'll be few and far between in this room. Windows Admin Center is a very lightweight, browser-based management experience for Windows Server. When I say browser-based, what that means is you can install it remotely on your client machine, and then just like any other application, you can launch it from the Start menu. So I have it installed on my laptop. So you can search for it in Start, you can launch it, and then it will open in your default web browser. So the only dependency is a modern browser like Microsoft Edge. Now you'll see we can add a connection. Initially, it doesn't know anything about my servers, but I can add a number of different connection types, including a hyper-converged cluster. The only thing I have to provide is the name, or if I prefer, the FQDN. And it will go out, confirm that that cluster exists and that it's running Storage Spaces Direct, find the member nodes, and import all of that into Windows Admin Center. And then I can click to open that connection and get to the Hyper-Converged Infrastructure dashboard. So this screen gives you an overview of your hyper-converged cluster. At the top, you can see alerts, which come from the health service. In this case, we have 2 alerts. They're telling us that some of our volumes are starting to fill up. And then below that, you can see the health of all of the key top-level objects that are part of a hyper-converged infrastructure. For example, the server nodes that are members of the cluster, the drives that those nodes are using to provide raw storage, the virtual machines, of course, and the data volumes, which are providing storage to those virtual machines. And in this case, I can see one of them is in a warning state and one of them is actually red because of those alerts there that they're getting very full. Continuing on down the dashboard, we can see an aggregate cluster-wide view of CPU usage. So this is across all of the nodes, as well as an aggregate view of memory usage and of storage across all of your data volumes. And last, but certainly not least, we can see performance across the entire cluster. So today there are 2 charts. You can see IOPS, the number of storage operations per second across the entire cluster, and the average latency, so how long each of those storage operations is taking. These charts are fully interactive, and you can change the time frame. So by default, they show you the last hour, but you can also look further back and see the last week, month, or year. And for each of these types of objects, so for virtual machines, or servers, or drives, or volumes, you can click in. And there are a whole sequence of additional pages that give you more detail and provide more actions. So here's, for example, a list of all of the volumes in this cluster. And I can see some of the actions that I can take, like open, create, expand, delete, and so forth. So that's a very, very quick tour of Windows Admin Center if by chance you hadn't seen it before for Hyper-Converged. And if you haven't installed it yet, I really encourage you to. A few things people ask us often is, how hard is it to get this set up, right? Because we always show demos where it's already set up. The answer is it takes less than 5 minutes to download and install Windows Admin Center. If you wanted to do it now, you'd be done well before the end of the session. It's very easy to set up. Does it have any dependencies, you might wonder? How much does it cost? It doesn't cost anything beyond the Windows Server licenses. So if you have Windows servers that you'd like to manage with Windows Admin Center, you can do so. It's free. And it does not depend on you setting up a SQL server. It does not depend on System Center. The only thing you need is a modern browser like Microsoft Edge, and you can get up and running. And it does not require an internet connection. Now, of course, initially you do need to download it, but once you have that, you can move it onto servers that are air-gapped with a USB drive or however you want to do that. And it does not need to regularly check the internet for day-to-day operations. Sometimes folks ask us, hey, how does this relate to System Center, specifically tools like Operations Manager or Virtual Machine Manager? And the answer is you should think about Windows Admin Center as the successor to the in-box tools that have always accompanied Windows Server. So tools like Failover Cluster Manager or Hyper-V Manager, those are the tools that Windows Admin Center is the successor for. They provide a foundational, basic set of in-box capabilities for managing a single server or, at most, a single cluster. But there are so many other things, like setting up email alerts and SMS alerts, or doing bare metal provisioning at large scale, or doing app monitoring across your entire data center that Operations Manager and Virtual Machine Manager do, which are unique capabilities. They've always been in a sold separately product like that, and they'll continue to be. And so the way to think of it really is that System Center and Windows Admin Center are complementary, and Windows Admin Center is the in-box management experience. Okay, so that's sort of the basics. I'd like to now dive into some more detail about Storage Spaces Direct and use that as an opportunity to show a little bit more of what Windows Admin Center can do. A topic we've covered every presentation since the beginning of Storage Spaces Direct is the built-in read and write cache. And what we can do with Windows Admin Center now is we can kind of peer into the inner workings. And so that's the demo that I'd like to do now. The read-write cache really gets at one of the core technology promises, the way that I see it at least, one of the core technology promises of Storage Spaces Direct. And that is that you have your entire set of data, and you should be able to have just the active working set on the fastest media. And then the rest of it, the data that you're not using, can be on what's maybe slower media. And the reason this is so important is that if you think about a hard drive, right, if we reacquaint ourselves with our good old friend here, a hard drive can only do 75, maybe 100 on a good day, random storage operations per second, random IOPS. And the reason it can only do this many is it comes down to physics, right? If we remind ourselves how this thing works inside, you have a platter. The platter is comprised of tracks. And then you have an arm that's actuated over the platter with a head on the end. And in order to read or write anything, you have to move the arm. It has some seek time. And then it has to settle on the track that you've selected. And then you have to wait for the thing to spin around so that the sector that you actually want to read is underneath the head. And all of that takes about 10 milliseconds. And so there's only 1,000 milliseconds in 1 second. And so you can only do that about 100 times. It's just physics. And it's kind of been this way forever. But I don't say all of this to knock on hard drives. Not at all, actually. Hard drives are amazing technology. You can consistently now, with 8 terabyte drives, get to consistent prices of below 3 cents a gigabyte. This is amazing. That's an incredible value. And so there's certainly a place for hard drives, but there's also weaknesses, right? And this is why this is how all of us in the storage industry get into having conversations about caching and tiering at all. It's to deal with these pros and cons of different types of storage media. Storage Spaces Direct supports 4 different types of drives at sort of the highest level. There are, of course, hard disk drives, HDD. We also support SSDs of the traditional variety, so SATA and SAS SSDs, which have NAND flash inside. We don't have very many requirements on either hard drives or SSDs. We also support SSDs that connect over PCIe, so we call those NVMe drives. Those are also comprised typically of NAND flash, but they have a faster interconnect so you can get higher performance. And with Windows Server 2019, we've added support for a new type of storage medium called persistent memory. Now you can deploy Storage Spaces Direct with 1, 2, or 3 of these types of drives. The most common configuration, though, is the one in the middle, which is 2. So most commonly, we'll see folks deploy a storage spaces direct environment with some flash, whether that's SSDs or NVMe SSDs, and with hard disk drives. So the way that that works, right, is in each of the servers in your hyper-converged cluster, you put at least 2 SSDs and at least 4 hard drives, and we support much more than that as well. And then Storage Spaces Direct will automatically choose which of those drives to use for caching and which ones to use for capacity. Having identified the cache drives on its own, it will then create bindings where each cache drive maps to some number of capacity drives. And these bindings are dynamic. So in the event that you want to add more drives later, you can add capacity or you can add cache independently. And if you add, say, more capacity drives, then Storage Spaces Direct will automatically rebind so that every capacity drive has a cache drive, and every cache drive has the same number of capacity drives that it's caching for. This is true when you scale out by adding drives, as I've shown. It's also true in another case, though, which is if something goes wrong. So if you have a failure, for example, one of your SSDs reaches the end of its life, then Storage Spaces Direct will immediately rebind so that those hard disks are bound to the surviving cache drive again. This is the reason we ask for 2 in each server node. This is different than something more like fixed disk groups, which some other platforms use, where if you lose the cache drive, the entire disk group is useless until you can replace it. So in terms of management, in terms of how much you actually interact with the cache drives are selected automatically. The bindings are also set automatically, and they adjust dynamically if you scale out, like for expansion, or if something goes wrong. The cache mode and the behavior, so the decision to cache reads and writes, is determined automatically based on the types of drives. And because it's a unified read-write cache, how much of it is used for caching reads versus caching writes is also completely dynamic. And all of this is independent of files, volumes, the storage pool. It's all at the physical device layer. And you've given us a ton of feedback that this simplicity, the fact that all of this just works without any kind of intervention, is amazing, right? I mean, once you've got your server node set up, once you've got your networking set up, for the most part, you just run enable S2D, and then you go get a sandwich, and when you come back, the whole thing is stood up, which is pretty amazing for technology that's that complex. So we've gotten a lot of positive feedback about this. But something else that you've told us is, well, you know, I can't really see into it. I can't really see what it's doing. It's a little bit of a black box. So I've got news for you. So today, we're going to open up that black box, and I hope you'll find it interesting. So to do that, I want to do a 2-part demo here. And the first part, we're really going to talk about write caching. Now, I'll be using an example where you have SSDs in front of hard drives. And so in that case, the cache will cache both reads and writes, as I've said. So let's talk about writes first. And let's think, why cache writes? Why should writes go to the cache first and then only later go to hard drives? And there are really a couple of good reasons for this. The first one is what we call coalescence. And that is what I've said. Random I/O to a hard drive is pretty slow. And you can actually, it turns out, squeeze up to about 5 times more IOPS out of a hard drive if you coalesce them in software, meaning if you deliberately optimize the movement of the head over the platter so that whenever it moves to a given track, it actually does multiple IOs on that track before making a move again. And if you can coalesce writes in that way, then you can push the hard drive to go faster. So that's one good reason that you should cache writes. Essentially, you need to create a queue so that you can reorder the writes before you write them to the platter. A second good reason is that you need to absorb bursts. So apps may or may not actually do their writes uniformly over time. In many cases, you'll have an application that will do nothing for some number of seconds or minutes. And then it will do a number of writes. And then the key insight is it will do nothing for some number of seconds or minutes. And if you can take that burst of write activity and you can amortize it over time, then it doesn't matter if your hard drives are too slow to absorb all of those writes because you're amortizing it over a longer period. And the third good reason to cache writes is that often applications will write a certain region of data, and then a brief while later, they'll overwrite it again. And maybe they'll overwrite it a third time. And wouldn't it be nice if we could only worry about destaging that final version? Like if all of those intermediary versions where the application was writing and then overwriting itself, if we could, of course, persist them on SSD, I'm not talking about memory, but persist them on flash and then only destage to hard drive once we believe the application is not going to touch that data again. So these are 3 good reasons to cache writes. And I'm going to do something here. So the 3 headings are going to stay the same on the slide, but I'm just going to switch it so that we have a little bit more of an internals view. So how do you do coalescence? Essentially, what you say is, OK, well, whenever I'm going to destage anything from the cache, I'm also going to destage adjacent pages. Because we've already moved the head to be on the correct track, and so it's already in place. And so I'll try to destage everything that I can that is adjacent on the drive. And in fact, we also progress from track to track in order so that we're doing a sweep across the platter as opposed to jumping around randomly. How do you absorb bursts? This one's a little counterintuitive, but the answer turns out to be you just destage at lower priority. So you tell yourself, all right, no matter how much the application is writing, I'm going to try to trickle it out and keep the hard drives busy in the background all the time. And how do you ensure that if an application is constantly overwriting its data, you only worry about destaging the final copy? You can do that by keeping all data in cache for at least some amount of time. So by default, we keep everything in cache for about a minute when you're write caching in front of a hard drive. And if somebody writes over it again, we'll reset that timer. And if after a minute the application has not touched that data, has not overwritten it, data tells us that it's likely that the application is done writing it and we can destage it. So this is a lot of talking, right? This is a lot of me waving my hands and explaining how it works. Wouldn't it be fun if we could just see it? If we could just watch all of this happen? And that's what we can do now with Windows Admin Center. So we're going to do a demo. I'll give you a quick tour of the environment that we're using. It's a very small cluster. And we're just going to do kind of an experiment to tease this apart. So you'll see if we take a look at the drives in this environment that we have 12 capacity drives. So these are our capacity drives. And we have 4 cache drives in total. So it's a fairly small little environment. The capacity drives are hard disks, as I've been talking about, and the cache drives are flash. And we can actually take a look at which server they're in, and you'll see it's just a 2-server cluster. So we've got 2 cache drives in each of the server nodes and 6 capacity drives in each of the server nodes. Now, this is a new environment. We've never done any reads or writes to it. We just enabled storage spaces direct. So what we'll do is in Windows Admin Center, we can quite easily create a volume for ourselves. The only volume that we have is that default cluster performance history one. Otherwise, we've never created one before. So we'll create our first. We can give it a name, for example, test. We'll leave the resiliency at 2-way mirror. And it doesn't really matter what size it is. We'll just make it 1 terabyte for simplicity. Because all we need is somewhere that we can do some I/O to run an experiment and see the cache in action. Now, in Windows Admin Center, we can actually open that volume. And we're going to upload a tool called disk speed, which is a micro benchmarking tool that we use to simulate storage I/O on Windows. So we can upload that into the volume. And then without leaving Windows Admin Center, we can actually open up PowerShell and run disk speed to synthesize the I/O that we need. So how we're going to invoke disk speed here is we're going to generate I/O for 300 seconds, which is 5 minutes. We're going to use 4 threads with a queue depth of 4 on each. The I/O is unbuffered, meaning it's going to go straight through memory. It's going to be random 4K I/O, and it's going to be 100% writes. So we're just going to do a boatload of writes, basically a 5-minute burst, to watch the cache in action. Now, one of the cool things about a browser-based tool is we can, of course, open 2 instances of it and snap them to sides of the screen. So we'll do that. And you'll see on the drive summary page for Hyper-Converged Infrastructure, we have this visualization of the write cache. We can see the total size, which is small because it's a small cluster. And we can see that there's 0 bytes of newly written data in the cache. Right? We haven't written anything. So let's start running disk speed. Now, you'll see that that is going to start filling up. And immediately, we've got almost a gigabyte in the write cache as we're doing all of this write activity. But what's a little bit interesting is if over here we take a look at a hard drive in the cluster, what you'll see is it's idle. It's not doing anything, because we're doing all of these writes, but they're going to the cache. And the hard drives, the capacity drives, are actually idling right now. We can see that they're going to the cache, because if we switch to instead look at an SSD, what you'll see is the SSD is actually quite busy. Indeed, this one is doing, it looks like 21,000 writes each second. But those are still just filling up that cache, and you can see it down there. If we play this forward, the cache is going to fill up until we've written 5 minutes worth of 4K random writes with 4 threads and 4 queue depth. which turns out to be about 115 gigabytes. Over here, we can stop time-lapsing. Over here, you can see that burst of writes that we've done. Again, this is a toy scenario, but we're just trying to see the cache in action, right? And we can do it now. So you can see we've done a 5-minute pulse of writes, but then about a minute into it, some reads started happening in blue here. What are those reads? We didn't ask for any reads. Why are we reading from the cache drives? Well, we're reading from the cache drives to destage to the capacity drives, and it starts about a minute in once some data has been in the cache for a minute. And you can actually see that indeed, about a minute after we started running disk speed, this particular hard disk was doing some random writes. And if we fast forward, we can watch destage play out now. So you'll see we have 100 gigs of new writes in the write cache. But if we time-lapse forward, mysteries of the universe notwithstanding, like why is the hard drive doing this? Nobody knows. But it's slowly destaging, and you can see the cache is emptying until it gets all the way back to having 0 bytes of newly written data in it. And that took about 40 minutes or so. So we amortized that burst, that 5-minute burst of 100 gigs, amortized over about 45 minutes. And you can see it. You can see it all in Windows Admin Center. And there's one more visualization that I want to show because I think it's kind of a nice summary. If we take a look at one of the cache drives, and we'll just full screen the page because we don't need 2 anymore. You can actually see, if you look on the far left or the far right, you can see the 5-minute burst of writes, followed by the long, gradual trickle of destages as we read the data from the cache and write it out to capacity. And so, I don't know about you, this is really neat. What do you think? This is a visibility into the inner workings that has not been possible prior to Windows Admin Center and Windows Server 2019. But it's just half of the picture, right? So we said it's a read-write cache, and so far we've only talked about writes. So let's talk about reads. Why cache reads? Same scenario, same SSDs in front of HDDs. Why should we cache reads? I hope this doesn't disappoint you. The answer is actually much simpler in this case. It's just frankly faster. Access time to a hard drive is, as I've said, at least 10 milliseconds on a good day. And we just don't want applications to have to wait that long. So if you think, this is a simplification, but think about an application that requests some data from persistent storage. It's going to have to wait until it gets that data back before it can continue doing anything else. And so if it takes 10 milliseconds to retrieve the data, it gets it, OK, great, it continues doing some computation. Eventually, it requests something else, and it waits for 10 milliseconds until it gets it. Now, if instead you could give it those reads immediately, the application would never have to stop, and it would actually probably request more reads every second. And so you have this phenomena that you see where if you can reduce the latency, you actually increase the IOPS. So that's the main reason to cache reads, is frankly that it's just faster and it's going to increase performance overall. The other reason, which is much more minor but is worth noting, is that if we're doing all of this work, as we talked about with the write cache, to optimize the movement of the arm over the platter so that the destage is as efficient as possible, every time you have to do a random read access to the hard disk, you interrupt that. And so you basically move the arm to serve as that read, and then you go back to destaging. And if we can, we'd like to avoid interrupting that. Same thing, I'll flip the slide to the internals. How do you operate a read cache? Essentially, we have a bitmap that tells us all of the regions of data that exist, and we track how often they're accessed. And any region that is accessed twice within an hour, we say, OK, statistically, it's very probable that it will be accessed more times again. So let's load that data into cache, and then all subsequent accesses will come from cache. And actually, we'll leave it there until it either gets invalidated or until we are running out of space because of, for example, a burst of new writes. And in that case, we will just take the least recently accessed page from the read cache and free it. That's a read cache in like 30 seconds. So let's take a look. Same thing. We can actually see all of this in action in Windows Admin Center. Here we are. It's the same environment, the same hardware, but actually we've torn it down and then rebuilt it from the software side so that the cache has never done anything. It's completely reset as a new environment. So just like before, we'll create a volume for ourselves called test. It can be a gigabyte. And then just like before, we're going to upload disk speed into that and run it from the Windows Admin Center PowerShell tool. Now, we're going to run it with a slightly different set of parameters, which I can start explaining early. So it's going to be, again, 4K random I/O from disk speed. But what you'll see is we're not going to run it for 5 minutes. We're going to run it for a little longer. In fact, we'll run it for 10,000 seconds, which is a couple of hours. Still 4 threads, still 4 outstanding I/O, still unbuffered, random 4K, but we'll do 0% writes this time. So it'll be all reads. And it'll be reads to this essentially imaginary file that we'll create that's 100 gigabytes in size. And so we'll just be doing random 4K reads from this for 10,000 seconds. Again, we can snap 2 windows side by side here, which allows us to do some fun demos. And you'll see in the drives tool for Hyper-Converged Infrastructure, down right next to where we had that visualization of the write cache, we have another one which shows us the read cache. And it shows us, of all the reads that are happening, how many of them are hitting the cache versus how many of them are missing. And so when we start, we expect that number to be basically all misses, right? Because nothing is in cache yet. So every random read is going to have to miss the cache and go to hard drives. And indeed, we can see that if we, on the other side, pop open the page for one of the hard drives, we expect to see that it's actually going to be doing I/O. So we'll pick a hard disk here from our list. And yes, indeed, right? It's doing as many I/Os as it can manage, which, as we've said, is not very many. And we only have about 6 of those in a node, and we're doing local reads because we have the opportunity to. So we're doing about 6 times 120 total IOPS for the cluster. It's not very many. If we time-lapse forward, though, as we start to request the same random pieces of data that we've requested before, we're going to be loading those into the read cache. And you'll see the hit rate for the read cache start to increase until eventually we're actually doing more reads from the cache than not from the cache. Now, as you'll notice, as this happens, the total performance of the cluster actually starts to increase, right? So we've gone from a few hundred to 1,000, and it'll continue upward. Now, notice that the number of total read misses is staying in the several hundreds, because that's just what our hard drives can provide. We're never going to be able to miss the cache more than a few hundred times a second. That's the sum of our 6 hard drives to be doing work. But as more and more reads are coming from flash, we're able to just answer them as quickly as we get the requests for them. And so the total performance of the cluster increases up into the tens of thousands as the hit rate gets to something approximating the steady state that we would expect, which is in the high 90%. Now, this graph of increasing IOPS performance as the read cache, we call this, by the way, warming up the read cache. That's only half of the story. The other half is, of course, the latency decreases. And those are absolutely correlated, right? At first, we're seeing something like hard drive latency in the tens of milliseconds. But as more and more reads are coming from SSDs, that number decreases down into the single digits and eventually toward 1 millisecond or even sub-millisecond latency, which is just the SSD performance that we're seeing. And again, same as before, it's kind of fun to see the whole thing from the perspective of a cache drive. And so you can see here that about an hour ago, the cache drive was mostly doing writes. Why was it doing writes? Well, because we were reading from the hard disk and loading it into cache, which involves writing into the cache. But then over time, as we missed fewer and fewer reads, there were fewer and fewer things that needed to be loaded into the cache. The number of writes decreases, and the dominant thing is actually just reads coming directly from the SSD. And you can see that on the far left and far right charts here as IOPS and throughput. So again, this is an example of how Windows Admin Center with Windows Server 2019 lets you see into the internals of storage spaces direct in a way that was not possible before. And a core focus for us has been to make this sort of thing straightforward, to make it so that you can easily get an intuition for how the system is working. Notice that I did not at any point here have to pick counters. I didn't have to know what it was that I was looking for. I didn't have to configure a custom view or move things around or set up this demo in an elaborate way. All I've done is look at the visualizations and the charts that are present in Windows Admin Center by default, and I can understand how the system is working. And so for the read cache, right, it's a cache hit rate. And I think all of us in IT know it. With cache hit rates, generally, higher is better. And that's true here, too. And for the write cache, it's a matter of how full it is. And like anything where you're measuring how full something is in storage, lower is better. And that's true here as well. And so we're not relying on anything like congestion or evictions or invalidations or any kind of product-specific terminology that you have to go learn. Because you shouldn't have to go learn that sort of stuff to get an intuition for how the system is working. This is really something that we care deeply about as we try to bring everybody from being an administrator of Hyper-V to an administrator of hyper-converged infrastructure. Now, I do want to acknowledge the engineering work that's gone into this, because to make it straightforward in this way has taken work at every layer, right? We had to actually build new performance counters, build a time series database so that we could store those counters, create a purpose-built API, and then work on the data visualization controls themselves to build those rich and colorful charts in Windows Admin Center. But this gives you an idea of how committed we are to making this stuff approachable. All right, what do you guys think? Was that cool? I'm really glad. I wasn't sure if it would be. Now, the cache is often associated when we talk about it with Storage Spaces Direct with our industry-leading performance. And many of you will have seen a demo that we did earlier in the week, so I promise I'm not going to do it again, where together with our friends at Intel, we built a 12-node cluster that was packed with a future Intel Xeon Scalable processor, persistent memory, and NVMe. And we used that cluster to take our previous industry-leading nearly 6.7 million IOPS from a single cluster and more than double it to over 13.7 million IOPS. Now, the way that we're able to do this, of course, a lot of it has to do with excellent software, but a ton of it is also the hardware that we support and that supports us. And in so many ways, Windows Server is on the leading edge of x86 hardware innovation, especially when it comes to the new storage and networking technologies that are being inspired by what the hyperscalers are doing in the cloud and that we can deliver to everyone's data center through Windows Server. We've supported NVMe and RDMA since the first time Storage Spaces Direct launched. We've supported Intel Xeon Scalable processors and Intel Optane since the day they launched. We also support Thunderbolt, and we've been doing a lot of work for persistent memory. And the secret sauce to that performance demo that we've showed earlier this week with Intel was Intel Optane DC persistent memory, which comes in modules that look like this one. They're DDR4 pin compatible, so they go into a memory slot. Now, I want to take a second just to talk about what's inside one of these. So the actual storage medium is something that's physically and chemically different than traditional NAND flash. It's actually a technology that's been jointly developed by Intel and Micron called 3D XPoint. And what you may not know is that while it is inside of an Optane DC persistent memory module such as this one, it is also available already, actually, inside of an NVMe SSD, such as the Intel Optane P4800X. Now, because it's the same 3D XPoint in both cases, you get many of the really cool properties in the P4800X that you would normally only get in that persistent memory module, one of them being very, very long write endurance. So a conventional NAND SSD today can do 1, maybe 3, maybe 5, or 10 if you're really buying the best drive writes per day. Intel's Optane NVMe cards are rated for 60 drive writes a day, which is a huge leap forward. And of course, it's not just endurance, it's also performance. And so you may wonder, how does a P4800X add-in card like that perform? So we ran the numbers. We'll use as a baseline our previous record for the most IOPS ever from a single cluster. So we'll use the baseline of 6.7 million 4K random IOPS. That was with a Broadwell generation Intel Xeon and Windows Server 2016. And earlier this week, I imagine most of you saw that we demonstrated very nearly 14 million IOPS with an Intel Optane DC persistent memory module. So the question is, how do the Intel Optane NVMe cards fit in? The answer is the performance is frankly excellent. It's actually over 10 million IOPS with these add-in cards, and that's without even persistent memory. And so depending on the exact capacity and performance trade-offs and needs that you have for your workload, and depending on the price point that you're trying to hit, you may find that these 3D XPoint-powered Optane NVMe cards are very interesting. So we thought this was a fun experiment to run, and we wanted to share it. I want to give one final thank you to our friends at Intel, both for the deep co-engineering relationship that we have with them and also for just lending us all of this gear. It's a lot of fun. So far, we've talked about seeing things, seeing into Storage Spaces Direct and understanding a little bit more about what's going on inside. But it's not just visibility and clarity that you get from Windows Admin Center. You can also take a number of actions. You can manage actively the system from within Windows Admin Center. And what I would like to show you is how you can install updates with actually just a very few clicks. Now, Windows Server supports a capability known as cluster-aware updating, where in a cluster, and this actually is not new in 2019. It's been available in Windows Server 2016 as well as 2012 R2. Windows will actually handle all of the end-to-end complete orchestration of installing updates onto server nodes that are members in a cluster. In plain speak, what that means is node by node, it will pause and drain, meaning move the virtual machines or workloads to other nodes, and then install the update, restart the server, and then resume it so that the VMs can move back, and then repeat for every node in the cluster. And out of the box, it comes with the ability to do this both from Windows Update and from Windows Server Update services. And it's also extensible by third-party partners who want to update other things using the cluster-aware updating engine. So this is all old news, I hope. We've made it even better in Windows Server 2019, and especially with an eye toward hyper-converged infrastructure. Two improvements that I'd like to highlight. The first is an integration so that it works best with storage spaces direct. It will now not only wait for storage spaces resync to complete after a node has rebooted, but it will actually proactively monitor the state of that resynchronization to ensure that it times out if the jobs are not making forward progress, but does not time out if they are making forward progress. So even with an enormous system like the one we showed from Quanta earlier this week, it will not time out. It will successfully install the updates across every node in the cluster. That's one change. The other change, which is designed to minimize VM disruption, is that it will no longer always pause and drain and restart if the update does not actually require it. So it will go out and figure out whether this update does or does not require a restart, and only if it does will it move the virtual machines to other nodes and then restart the node. Otherwise, it will install the updates with no disruption at all. So that's a nice set of improvements. And there are others. So there's new flags and parameters in the commandlets. We've improved the debuggability and a number of other things as well. But the thing that I'm most excited about with cluster-aware updating is actually just the new experience in Windows Admin Center. So I'd like to show it to you. It's so simple compared to what you may have used before. So here we are on the Hyper-Converged Infrastructure dashboard, and you'll notice we've added a new tool. This is brand new. This was only added last week, called Updates. Now, I'll click it to launch it, and you'll see it'll ask me to enable the credential security service provider, which I'll click yes. And then it's going to spin for a little while. Now, if you've ever used cluster-aware updating before, then you know you have to go enable, set up a role and set up a firewall rule, and there are a number of steps you have to take. And what it's doing while it spins here is it's actually doing all of that for you. And so you just have to wait, and just like that, you're ready to start using cluster-aware updating. Now, if you've used the Windows Update tool in Windows Admin Center, this should look familiar because it looks the same. And just like with any other Windows updates, you can click Check for Updates. It will verify what is on every node in the cluster and then reach out to Windows Update and determine if anything is available for these nodes. In this case, I have a Windows Defender definition update available for Node 1 and for Node 2. By a quirk of the fact that I built this cluster out of order, Node 3 actually already has it. But I have these two updates that are available. And all I have to do is click Apply All Updates. And you'll see the run state switches to Run in Progress. Now, I don't really want to make everyone in the room watch paint dry, so we'll come back in a few minutes later. And you'll see that that status will switch to Succeeded because I've installed the updates on each of these nodes. Something that, I don't know if you guys know this, it's really neat. You can actually close your browser and then come back later, and Windows Admin Center will queue up the notifications for you in the notification tray. It's really neat. So I can see exactly when the update finished, if that's important to me. I can also get an update history, and I can see that nodes 1 and node 2 both succeeded the update. And then I can click Check Available Updates, and I would expect, once it comes back, that I have nothing to update. And I can do this whenever I want. I can click Check for Available Updates, and if there's anything that I need to update, I can click Go, and then go get a sandwich, and Windows will handle all of the orchestration across the entire cluster for me. I don't have to worry about anything. What do you guys think? Pretty neat? Now, cluster-aware updating is sort of one piece of the core cluster management experience that you need for hyper-converged infrastructure. But there are a number of other things that we're also enabling within Windows Admin Center. One of them relates directly to another one of the core technology promises of hyper-converged infrastructure, and that is the ability to scale out or scale in seamlessly as the needs of your organization change. This is so important. It's one of the main reasons that customers are moving to a hyper-converged architecture. And now you can do it within Windows Admin Center. So there's something that works a little bit differently when you have a hyper-converged infrastructure compared to a cluster that you may be familiar with from before. If you have, for example, 2 nodes, as I've been using for many of these demos, and then you add a 3rd node to the cluster, it will have, one hopes, the same arrangement of drives inside, but those drives will be empty, right? Any storage that you provisioned on the 2-node cluster is only on those 2 nodes, and it's not, the drives on the 3rd node are still completely empty. What's cool is that without you having to do anything, Storage Spaces Direct will actually rebalance and redistribute all of that data over so that it's using all 3 nodes equally. And you can see this happen in Windows Admin Center. So here I have, as promised, a 2-node cluster. I can see them. And I can just click Add. This is a new button that we added last week. I can provide the name of the 3rd node that I'd like to have join the cluster. And then I click Add. It's really quite straightforward. Just like cluster we're updating, it requires CRED SSP, so I'll go ahead and click Yes. And then this will go out and not only add this node to membership in the cluster, it will also take all of the drives from this new node and add them to the storage pool. And so I can see here's that 3rd node, part of the cluster. I've got them 1, 2, 3 now. And I can go over and take a look at my drives, and where I had 16 before, I now have 24 drives. And actually, I can group them by server, which is kind of a fun capability. And what I'll see, as I expect, is that the drives in the 3rd server are empty, right? Because we just added this node. But Storage Spaces Direct, without me having to do anything, is going to kick off a job where it will go and rebalance the storage pool to move data over onto that 3rd node. And I could sit here and watch it happen, and that job will potentially run for a long time if there's a lot of data that it has to move. But it will equilibrate the storage utilization, not only across the nodes, but also across all of the drives in all of the nodes. That's 1/2 of the scale in, scale out flexibility promise, right? It's just 1/2. It's the scale out half. What about if you want to scale in? Who has worked with a Storage Spaces Direct cluster and attempted to remove a node from the cluster before? Some folks, yes. And what you may have experienced is that if you use an older tool like Failover Cluster Manager to do that, then you say, OK, I would like to remove node 3 from the cluster. And what happens right away is it just succeeds. The node's gone from the cluster, and poof, it's gone. But those drives that we were relying on, we had allocated data to those drives. Those drives are now missing because that node's gone from the cluster. And the technical term for what happens in this case is the sad face emoji. So what you can do now, what you would ideally want to be able to do, is to say, hey, I intend to remove server 3 from the cluster. And you would like for Storage Spaces Direct to actually redistribute data back off of those drives onto nodes 1 and 2, and only when those drives are really and truly empty should they be removed, and then the node can leave from the cluster. And now you've scaled back in down to 2. That is ideally what you would like. And now you can do it in Windows Admin Center. So from the same page here, you'll see we have the 24 drives in the cluster because we just added the 3rd node. From the servers page, right next to where we have that add button, we have a remove button. But what's new, what's never been in a graphical UI before, is this little checkbox where you can say, actually, I'd also like to remove the server's drives from the storage pool, please. You check it, you click remove, and again, you have to enable CRED SSP. And in this case, it'll succeed quite quickly because actually no data had balanced onto those drives yet. But you'll see the drives are gone from the storage pool. We're back down to 16. And if there was data to move, it would have waited, and it would only have removed the node once the data was removed from those drives, which is really nice. It really delivers, for the first time, truly on that flexibility to scale in and scale out easily, all within a couple of clicks. I have one more demo that I'd like to show about core cluster and server node management. And that is the ability to validate the cluster. Many of you, I'm sure, are familiar with this already. So within that servers tool, as you may have seen, we've added quite a few buttons, actually. So we've added the add button, the ability to remove, of course. But take a look at the next two. So you have the ability to run cluster validation from within Windows Admin Center, as well as the ability to view validation reports. And this, I think, is actually kind of cool. So if you click, what you'll see is you can pick any time that you've ever run cluster validate from the entire history of the cluster since the beginning of time. And you can pick which report you want to view. If you want to see it in the good old format, you can download the report directly onto your machine, onto your client machine here. But you can also browse the report directly in Windows Admin Center. We've got this whole new beautiful look where you can expand any of the sections. If you see something that was a warning, you can pick the exact test and see all of the details, all within Windows Admin Center. So these are 3 examples, add node, remove node, and cluster validate, of how we are reinvigorating the core cluster management experience in a way that has hyper-converged infrastructure built in from the beginning using Windows Admin Center. Hopefully, you're getting the message that Windows Admin Center really is the future of the in-box management experience for Windows Server, and especially for hyper-converged infrastructure. On this slide, you can see a number of the actions that are already possible in Windows Admin Center today, as well as a number that are highlighted in blue, which are on our roadmap and which we will add over the coming months and as needed years. All right, we have been talking about Windows Admin Center for a while now, and it's time to switch gears a little bit and talk about some core capabilities in the platform for Storage Spaces Direct. We often show this slide, which lists all of the important enterprise-grade features that Storage Spaces Direct provides as a storage platform. And I'll stall for a second so that everyone who's taking a photo of it can finish. And then I'll talk about one that's kind of been missing and that we're really excited to add in Windows Server 2019. All right, your time's up. And it's deduplication and compression. This has been one of the most requested features for Storage Spaces Direct, and we're so excited to be able to deliver it in Windows Server 2019. Previously, deduplication and compression was not available with the REFS file system, which was the recommended file system for Storage Spaces Direct. Finally, you can bring them both together and use them both with Storage Spaces Direct. Deduplication and compression is a really big deal. It enables you to get, in many cases, a significant amount more usable storage just for free for turning it on. The amount of usable capacity that you get depends on the type of data that you're storing. And so for a file server that's sort of a general purpose file server, you can get somewhere in the ballpark of about 60% savings. If most of the files are things like photos, videos, or music that are already quite well encoded, the savings will be less. And we say that if you are storing virtual hard disk files, ISO files, or backup, the savings can be up to 90%, which would mean you would get 10x more storage for free. I don't know about you, that seemed almost too good to believe. So I'm sitting here looking at this slide, and I was like, I would really like to actually try this on a real representative workload that people do on hyper-converged infrastructure. Now, it was a little bit awkward to ask an external customer for their data because I was just basically saying, hi, can you give me all of your data? So instead, I found an internal customer. I found the Microsoft Edge team. Now, it turns out the Microsoft Edge team has to run tests every day to ensure that Edge is working the way that it's supposed to. And the way that they do this, how would you do this if you had to? I would do it in virtual machines on hyper-converged infrastructure. So that turns out to be exactly what they do. And so you can actually kind of watch this happen. It's fun. They have all of these virtual machines, and they're just constantly accessing all of the most popular web pages on the internet, making sure that Edge works the way that it's supposed to. And all of this data is being stored as VHD files. It's as repetitive, or not repetitive, as any other hyper-converged workload. And so what I decided to do was to enable deduplication and compression on the REFS volume where the Microsoft Edge team was storing their files. So let's take a look. So in Windows Admin Center, you'll see what I've done is I've created 2 volumes. One of them's called with deduplication, one of them's called without. They're both two-way mirroring. They're both the same in basically every way. And to show that, I'm just going to open the 2 volumes on separate sides of the screen here by opening 2 tabs of Windows Admin Center. So you'll see the first one has 688 gigabytes used, and guess what? The second one does too, because I took all the files that the Edge team gave me, and I just put them all in both volumes. So you can browse those files directly in Windows Admin Center, and you can see maybe some project code names from the future, actually. And you can see all of the same files are over on this side as well. Now we'll go back, and I want to call out that at least at the moment, deduplication is actually turned off on both of these volumes, right? And so we have the 2 so that we can do a comparison. So we'll turn deduplication on one of them. OK, so let's do that. There's a simple rocker switch, as you may have seen. I know Dave did a session on this. And all you do really is click that rocker switch. It really couldn't be much easier. There's no complicated configuration or settings. You have one thing you can choose, but you don't even have to. You just click Start, and deduplication is enabled. Now, what you'll see is it shows you the savings both as a raw number, the number of gigabytes that you've saved, and the percentage. But what's kind of fun is you can also just time-lapse forward and see the used space in the volume start to decrease as deduplication is going, finding common chunks of files and only storing them a single time. Now, one thing that I think is even extra cool, since I'm kind of a geek about the internals of this system, is you can actually look at what the read-write workload of a deduplication job looks like. And so you can see it's reading a lot, but it's finding only very rare unique pieces that it actually has to write back out. For the most part, it's just reading and saying, yep, this is the same piece as I've seen before, and so is this, and so is this. And eventually, about an hour later, once the job is complete, you'll see that we've saved 89% of our storage. We've compressed what was 688 gigabytes down into 73 gigabytes, which means the Microsoft Edge team, thank you. That means the Microsoft Edge team gets 10 times more usable storage for free. That's deduplication and compression. And just to show you that there's no funny business going on here, there's a neat trick. I'm just going to get nerdier and nerdier as this goes on. You can actually write a PowerShell script that will recursively get all of the files and all of their sizes and names and folder structure on both sides and then hash it. And then you can see that the one that has not had deduplication run on it has that hash, and the one that has had deduplication run produces the same hash, which means to any user or any application or anybody above the file system, you can't even tell this is turned on. It looks the same, and yet you're getting that 10 times more storage for free. It's kind of a neat trick. All right, now occasionally, customers tell us that even with this kind of space-saving feature, they need very, very large raw capacity in their storage spaces direct cluster. And so you may have seen that earlier in the week, we did a demo because with Storage Spaces Direct in Windows Server 2019, we now support up to 4 petabytes of raw storage in a single cluster. So we did a demo earlier in the week where with our friends from Quanta Cloud Technology, we actually built such an environment. And I'm just, for anyone who missed it, we actually set what I believe to be the largest Storage Spaces Direct cluster ever by capacity at over 3.5 petabytes. It was, I'm sure, expensive for somebody to get all this gear in one place. I didn't pay for it. So I want to just thank QCT for their collaboration on that. But that's really the big end, right? That's our ability to go huge with Storage Spaces Direct. Customers are they're also going small. Right? Storage Spaces Direct, one of the key technology promises is that scalability, the fact that you can deploy the same architecture in your core data center as well as at the edge in a remote office or branch office. You can use the same software stack, the same set of management tools, and it's simply scalable enough to meet both of those requirements. And so we've been doing a ton of work to make hyper-converged infrastructure on Windows really great at the edge. We support switchless back-to-back networking so that if you have in a branch office just those 2 machines and you don't want to have to set up a switch, you don't need to. You can actually simply direct connect the 2 nodes together. We have a full active-active model for both compute and storage, which means that those 2 nodes, the virtual machines, will some be running on node 1 and others on node 2. And they'll be doing reads and writes to the storage at the same time on both sides. We also have the lightest weight quorum technology in the industry, so you don't need a costly witness VM appliance to make this work. It really, truly is a 2-node cluster, period. We've also recently added the ability to use a USB key or any NAS, even if it does not join Active Directory, as the witness for such a cluster. And something that I want to demo next is a new feature called nested resiliency. Now, in the interest of time, I'm going to skip a few sections and get to nested resiliency and really what it does for one of our core technology promises with Storage Spaces Direct. And that is to give you RAID-like protection and fault tolerance for your data without the need for any specialized or expensive hardware. Now, on Windows Server 2016, if you had a 2-node cluster, one of these small clusters at the edge in a remote office or a branch office, the only resiliency that was available to you was what we called two-way mirror, which is to say we would store all of the data on one node and we would also store all of that data again on the other node. And so you would always have 2 copies of everything. And I can actually show you what that does, right? So in Windows Admin Center, we can see here that we have our 2-node cluster. There are the 2 nodes. Both of them are quite small. It's actually the same cluster that I used earlier for the cache demos. And I'm running 6 virtual machines. And what you'll see, first of all, of course, there they are, is that some of them are running on node 1 and some of them are running on node 2. Because this isn't like an active passive where we just have a secondary waiting. It's really truly that both nodes are full members of the cluster. And I can see that this virtual machine, for example, is storing its files on C cluster storage volume 1. Because this is a hyper-converged cluster, and that's a volume that Storage Spaces Direct is providing us. And I can actually click a link and go directly to the page for that volume. And I can see that it's using two-way mirroring, which means the total volume size of 1 terabyte is occupying 2 terabytes of footprint. So both of my servers are up right now. But the whole reason we're doing this, both HA for the virtual machines as well as replication for the storage, is that we want to be able to tolerate failures. And so if we have a drive failure, for example, or if we have a server failure, an entire server failure, we would like for the virtual machines to continue running. Ultimately, that's what we care about, right? And so I can show you how that works. Suppose we take one of the nodes and we just pull the plug so that it's down. If we go over and take a look at the virtual machines, what you'll see is all 6 of them are still running. You can actually already see that from that page. So there's the 6 of them, and they're running. But what's changed is instead of some of them being on node 1 and node 2, they're all now on node 1. Now, that's the familiar part. The part that's special with Storage Spaces Direct is that, of course, when the node is down, half the drives are missing. Right? So you can see all of the drives in the node that's down. Those drives we can't communicate with anymore. And yet, those virtual machines are still up and running because they're still able to access their storage because the storage was using two-way mirroring, and we had a copy in the node that's still up as well. But with two-way mirroring, there are some limitations. Right? This was all we had in Windows Server 2016. And what happens if, heaven forbid, something should start to go wrong on the other node? What happens if, oh geez, what happens if that drive fails at the same time that that node is down? Well, in that case, you've got failures on both sides. Neither of your copies has all of the data available. And so the storage, the volume that we created, is going to go offline. And it goes offline because, frankly, there's just too many drives missing all at the same time. And so you can see the alerts. You can actually read right from the dashboard what happened. So we lost connection with one of the nodes, and then we had another drive fail, and now the volume isn't accessible. It just reads like a children's book. And you can see the virtual machines are all turned off, right? Because their storage is gone. So what are they going to do? So this was sort of the limitation with two-way mirroring on a 2-node cluster in Windows Server 2016, is that you could not tolerate 2 failures at once if they were in different server nodes. And a point of feedback that we got often was, hey, it would be really great if you could somehow solve this problem. Impossible though it may seem, it would be really nice if there was a solution. And so in Windows Server 2019, we're super thrilled to introduce a technology called nested resiliency, specifically designed to address this problem for 2-node clusters. Let me explain a little bit how it works, right? So the goal is that we can have a volume on a 2-node cluster that can handle 2 failures at once, even if they are in different nodes, which is a little bit surprising. To figure out how this would work, we took inspiration from actually a pretty old RAID technology. So let me give you a quick demo, and then I'll explain what you've seen. So in Windows Admin Center, we've basically reset the environment back to the way that it was at the beginning. And so you'll see we've actually still got that volume from two-way mirroring, but we've created 2 new volumes, which are 2 different flavors of nested resiliency that we're offering with Windows Server 2019. One of them has an enormous footprint. So for 1 terabyte of usable space, it's taking up 4. That's a new low for us. The other one is actually much closer to two-way mirroring. So 1 terabyte of usable storage is taking up less than 3 terabytes. So it's actually more efficient than 3-way mirror. And we've got our 6 virtual machines that we've moved their storage, and then we've started them up again. And so here they are. Some of them are running on node 1. Some of them are running on node 2. And if we take a look at the storage, you'll see that it's in volume 03. Some of them are on volume 02. The point is they're on the nested resiliency volumes, not on the two-way mirror one. So just like before, let's simulate the same set of failures. Let's take one of the nodes. We'll bring it down. And that will take down half of our drives, right? All of the drives that were in that node will be gone. And then, just like we did before, we'll create an additional failure as well in the other node. And so there's our 8 drives down. And then we can just literally yank a drive out of the other node. So now we've created that situation that previously we could not have stayed up for, right? We would have had downtime in this case. And yet, if you look, so the volume 1 is offline, of course, because it's two-way mirroring. But look at these other two. Yes, they would like to repair, please, but they are both still a green check mark. They are both still up. And what that tells us is the virtual machine should be running. And I'll keep everybody in suspense for just a quick moment, right? We can pop it open, and clearly we can still access it because we're able to browse all of the files. So here they all are. Here's the VHD files for the virtual machines we put on this nested resiliency volume. We can access them all. And notice, by the way, that where we have volume 2 and volume 3, which are mounted, they are accessible. Volume 1's gone, right, because it was using two-way mirroring. And so indeed, we can go all the way back to the dashboard and see that, yep, our virtual machines are still running, even though we've had failures on both sides, even though of our total of 16 drives, more than half of them aren't even here anymore. Everything is still a go, which is pretty cool. What do you guys think? So as I said, the inspiration for this was a technology that's certainly not made at Microsoft. It's called RAID 51 or RAID 5+1. And the general idea, to give you a conceptual sense for how it works, is we do single parity within each of the nodes. And so we'll have a bunch of data, and then we'll write a parity column on one of the drives within that node. And then, over top of this, we will actually mirror all of it onto the other node in the cluster as well, effectively giving us the same parity within the other node. And now within either node, losing a drive is totally fine. And you have the same data on both sides, so losing, even if you have a drive lost on one side, losing the other side is irrelevant. And so you can survive two drives or a drive and a node at the same time. And as you saw in the demo, we offer two different flavors of this. One of them is simply two-way mirroring on top of two-way mirroring. That's the one that has 25% usable storage efficiency. The one that probably more folks will be interested in is called nested mirror accelerated parity, where we do essentially mirroring on top of parity, like in RAID 5+1. And that one gives you a storage efficiency that's actually quite comparable to what you would get with plain old two-way mirroring. It's actually, in many cases, near or even over 40%, which means that if you are of the view that storage is cheap but downtime is expensive, you will probably find this feature very interesting for your two-node clusters, because where you would have gotten from 50 terabytes of physical, you would have gotten 25 before with two-way mirroring. You actually fully get 20 usable this way, and yet you can tolerate failures on both sides, which is really a huge leap forward. All right, now, in the interest of time, I am going to skip forward some, and I want to take the last couple of minutes to give you some important updates about the product. So we've talked a lot about the technology from the lens of a technologist, right? What are we doing with Storage Spaces Direct? How does it work? What's new in Windows Server 2019 for Storage Spaces Direct? Let's talk about just the state of the product in general and its place in the market. Some of you may have seen that earlier this year, we were actually the winner of the Computer Resellers Network Product of the Year for software-defined storage. So every year they pick a number of finalists who provide the most useful, well-crafted, and innovative product in software-defined storage. Not only did they choose Storage Spaces Direct as a finalist, but we actually won. So that was a very nice accolade that we're quite proud of. We also recently debuted as a visionary in the first ever Gartner Magic Quadrant for Hyper-Converged Infrastructure. And we expect the next Magic Quadrant to be coming out later this year, and we're really looking forward to seeing how we rank there. Earlier this year, in March, we also shared that there were over 10,000 clusters of Storage Spaces Direct deployed around the world, which is phenomenal adoption. We're really deeply humbled by that. And this week at Ignite, we have the pleasure of giving you an update on those numbers. It turns out that in just the last 6 months, since March, that number has increased by over 50%. So thank you all very much for the faith that you place in us and in Storage Spaces Direct. Now, I imagine some of these clusters are from folks in the room. And in fact, I know one example that is. We have a couple of folks from Bradley, which is a leading national law firm with a reputation for skilled legal work and excellent service. And Bradley has an interesting challenge that I'm sure many of you can relate to, in that they have a number of distributed sites across a significant swath of the United States. They have actually 9 different offices, each one of which needs to run some distribution points for Configuration Manager, AD and DHCP, some emergency response systems, as well as some SQL workloads. Now, originally, each of those branch offices was running on VMware vSphere on top of a Synology iSCSI NAS. And a couple of years back, the team at Bradley decided to upgrade and really modernize both their data center as well as their branch offices. And so in every branch office, they moved from this old architecture to a new architecture of hyper-converged infrastructure powered by Storage Spaces Direct, which of course, because those 2 nodes in each branch office are now bringing their own storage, they actually don't need any standalone storage at all. This was such a successful experience for them that they ended up doing a similar modernization in their core data center, where they actually deployed what is now a 7-node cluster. It's been growing slowly but surely. A 7-node all-flash cluster that actually has Intel Optane in it as well, the NVMe cards that I mentioned earlier. So far, they have rolled out Storage Spaces Direct to 4 of their sites. They have 2 of them in progress at the moment, and there are 3 more coming before the end of next year. They're planning on upgrading every location to use Storage Spaces Direct hyper-converged infrastructure. So it's a really great story. One of the things that stood out for them was that Storage Spaces Direct, and I quote, is a breath of fresh air from a cost perspective. When they ran the numbers, they determined that it was actually less than half the cost to deploy Storage Spaces Direct in this way than it would have been to achieve a similar architecture, but with traditional storage, less than half of the cost. Now, this is just one customer story among many. We actually have an entire set of stories which are published online and that you can go read. There's folks from all around the world in many different verticals and from many different partners as well. The good news for folks who saw cost savings with Storage Spaces Direct is that that is absolutely going to continue. So going forward, Storage Spaces Direct is included in the Windows Server 2019 data center license, just as it has been in the Windows Server 2016 data center license. So it's still no additional cost. If you run Hyper-V at scale, it's effectively free for you, just as it's always been. And we still support the same 2 options to procure hardware for hyper-converged infrastructure on Windows. The first being that you can build your own using parts from the Windows Server catalog. You can basically mix and match to your leisure. The only requirement is that they must have the software-defined data center additional qualifications, or the SDDC AQs. And those can be seen quite clearly in the Windows Server catalog. That's one option. The path that we really recommend, though, is to go with a pre-validated and ready-to-go offer from one of our partners. We have been working with all of the leading server vendors in the industry. We have over a dozen partners now who are actively testing and validating hardware for Storage Spaces Direct. And these partners, among whom nearly half are new this year, have collectively tested over 50 different hardware configurations, which are now certified and validated and available as ready-to-go solutions to run Storage Spaces Direct. You can browse them on our new website, which is microsoft.com/WSSD for the Windows Server Software-Defined Program. And in many cases, you can actually simply click directly to a partner website where you can browse the entire bill of materials and buy them if you so choose. We'll be launching the first wave of WSSD pre-validated offers for Windows Server 2019 early next year. So in the mid-January, we're going to have a launch event for the first set of validated hardware on Windows Server 2019. For now, those other 50 offers are available for Windows Server 2016, and the partners I know are hard at work preparing for this launch event that's barely 3 months away now. All right, so to wrap up, first of all, I want to thank you all for being here. I hope you've seen things that you found interesting, and I hope you learned something. And I hope we've convinced you that with Windows Server 2019, there is a lot of new value that helps you to do more with Storage Spaces Direct. We didn't have the time to show everything today. There's just too much to say. But with Windows Server 2019, you can really unlock faster performance with Storage Spaces Direct, scale even bigger. You can increase resiliency at the edge with nested resiliency for Storage Spaces Direct. You can achieve greater efficiency with data deduplication, open up the black box with those kinds of demos that we did where you can see into the inner workings of the system. And there's so much more that we've shown before at the Windows Server Summit and that we'll continue to document and put online so you can catch misbehaving drives easily. As we showed, you can roll out updates with a single click. Ultimately, you can modernize your data center with Storage Spaces Direct. Okay, I hope you enjoyed this content. If you did, please install Windows Admin Center, take Windows Server 2019 for a spin, get ready for that WSSD launch event that we'll be having in January, and of course, please take the time to review this session. Thank you all very, very much.